Hello and welcome back to my Astronomy Nights. I'm Derek, and in this video I'm looking at Messier 45, the Pleaides cluster, that wonderful naked eye open cluster in the constellation of Taurus. I had the chance to get out over the last few weeks and image and observe this one. I was using my 82mm refractor alongside my large 12-inch Dobsonian, and I was primarily trying to observe NGC 1435 or Tempel's Nebula, that small nebulous cloud around the star Merope in the center of the cluster. So in this video I'm going to look at what it is, some of the early observations of it, and how it might look through your eyepiece or imaging setup. So let's begin by locating Messier 45 on the night sky. To locate Messier 45, it's quite easy. It's a large naked eye object, but when you're trying to orientate yourself in the night sky to find the right direction, look for the large constellations of Orion or Taurus, or you can look for Gemini as well. And if you see those winter constellations, you want to follow the red stars of Betelgeuse on the shoulder of Orion and Aldebaran in the center of that V shape in Taurus, and you can just follow that line straight through up to say west northwest, and about 10 degrees past Aldebaran you'll see that large light cluster of bright white blue stars, and that's the Pleaides cluster. Messier 45 is a wonderful naked eye open cluster in the constellation of Taurus. It's a grouping of stars about 440 light years from Earth, and it takes up about 2 degrees on the night sky, shining with a magnitude of 1.5. This has been known since antiquity. It was even a constellation at one stage, so it doesn't have an NGC designation. However, Charles Messier did add it into his catalogue as the 45th member. His catalogue was originally for anything that looked like comets that was being mistaken for comets. So if you did see the Pleiades in that early morning sky or late evening sky, it could be mistaken for a bright comet. German astronomer Whilem Tempel observed this in 1859, and when he was observing it with his 4-inch telescope, he noticed that there was a nebulosity just to the south of Merope. He described it as being a large bright nebula about 30 arc seconds in length just south of the star Merope. So even though the nebula was easy to spot in smaller instruments, it wasn't until Isaac Roberts, the Welsh astronomer, took a long exposure photograph of the Pleaides and he was able to confirm the nebulosity existed. In his book, Photographs of Stars, Star Clusters and Nebulae, he stated that the Merope Nebula extends from the star to the distance of about 40 minutes of arc and faintly covers an area of about 50 minutes in width in the south preceding and the south following directions. The Maya nebulosity also extends about 40 minutes of arc in the north following direction, and after creating that long exposure photograph, he stated that it appears to me that the evidence taken as a whole points strongly to the probability that the Pleiades consist of a group of stars seen by us either behind or in front of the group of nebulae, Alcyon, Merope and Maya being involved in nebulosity, thus confirming that there was nebulosity around the Pleaides cluster. There's 5 main types of nebula that we observe in the night sky. 2 of them are stellar in origin, and that are planetary nebula and supernovae remnant. So what you have with the planetary nebula is a low mass star casting off that outer gas, and you end up with something like the Dumbbell Nebula or the Ring Nebula. And then on the other hand, larger mass stars have that more cataclysmic kind of explosion that sends out that shock wave of material, and that will give you something like the Crab Nebula or the Veil Nebula in Cygnus. So the other 3 then are made up of the interstellar medium. You have emission nebulae, and these are where the gases around star forming regions are being ionized by large O and B type stars that give off lots of UV radiation, and then it ionizes it and they give off that light towards us and we can see them in the visible spectrum. Then on the other hand, you have a nebula made up of interstellar dust, and this is where you can have dark nebula that are obscuring the background stars and that short wavelength of stars behind them. And you also then have that same dust in clouds around our galaxy that reflect blue light towards us. So that short wavelength is bouncing off those clouds and it's kind of scattering all the red. So you get that blue look to a reflection nebula. There's some examples of this where you have in the Trifid Nebula or Cocoon Nebula, where you can see those blues and reds and dark nebula all together. So you have your emissions in the red, your reflection nebulas are blue, and the dark streaks across it then are that dark nebula where the clouds are obscuring the background stars. So to get my data for this one, I was using my Evolux 82mm ED refractor from Skywatcher, and I had it on the INI-Q6 mount. I used my monochrome camera, the QHY163 mono, with RGB filters from ZWO. I was trying to get a good image of this because I wanted to capture the nebulosity that I had been observing on a really clear night. So I only got an hour and a half of each on the same night, the nights that I was trying to get an image of the Rosette Nebula, which I will look at later in the year. But I was kind of running out of time to get these targets because they are pushing a little west. So I was getting these images with my 82mm refractor. I ran an hour and a half on the red, blue and green channels on this one, and I was quite happy with the results. The monochrome image is really nice, and then when you bring out that nebulosity around the stars, it really shows up. It's almost like it's got lines and streaks through it. So initially I thought, oh, maybe I was stretching the image a little too far. But actually when you look at other images of it, you can see there's some really straight lines within that nebulosity. So for my observation sessions on this one, I was limited to using my 12-inch Dobsonian because I had my refractor doing my photographs at the same time. So it was a little trickier to try to observe something that's advised to use a smaller instrument on, but I tried my best anyways. I used my 24mm and 32mm eyepieces in my Dob, and I had luck with the 24mm. I think the key was keeping those bright stars right out of sight of the field of view as you're observing it, and using plenty of averted vision. I think trying to look directly at that kind of tenuous blue light, like it's obviously it's grey to us, but the star and that are shining at that same blue light, so it's really tricky to distinguish kind of stray starlight from it. So if you take your time though, you can kind of just keep those stars sitting outside the field of view as you're observing it. If you have a smaller instrument, I'd really like to hear how you get on with this specific target, because I'd be looking at finding something that kind of sits a little better for this target to observe it. I think my 80mm was a little bit on the small side, and then my Dob was a little bit on the big side. So I will try my 8-inch, but I mightn't get it again because by the time next new moon comes around, trying to get a clear night on new moon in Ireland is pretty tricky. But if I do get lucky, I will give it another observation. I might put my 8-inch onto my mount if I can. So for my observation sessions of Messier 45, I used my 12-inch Dobsonian, I had my 82mm refractor on a different night, and I also used my 2x Helios binoculars as well at the same time. I found this as a great target for wide field observations. It's really fun to observe this with the naked eye and try to see how many of those stars you can spot. From my location, I'm able to get 8 of these stars, which is really nice. I think I used to be able to get 9 when I was younger, but I think the older your eyes get, this is a real test on them. But with the 2x binoculars, it's a really lovely target to observe, because you can see a lot of those stars just beyond magnitude 6, but you're still seeing it in nearly the same field of view as naked eye. When I turn my telescope on this to try to see that hazy nebulosity amongst the stars, I was using my 12-inch on the night of the photograph that I took, which was around new moon, and I was able to just push Merope out towards the edge of the field of view on the eyepiece, and you could just see that lovely grey haze throughout the background. It doesn't have any kind of definition to it. It's really just, if you push the telescope kind of back and forth, you can just see the way the background stars kind of drop in and out. Kind of similar, it's kind of like a similar view of, say, the Rosette Nebula when you're looking at that that visual part of the Rosette Nebula, where you're kind of seeing where the stars change, and you can see all that kind of the grey light from it. I think over the next few years this is a target that I'm really going to try to observe more often. Like the Pleaides is always a naked eye target, is always a binocular target, but I never tend to put my telescope towards it. So I think the fact that this nebulosity is there and available to view through your eyepiece, I'm definitely going to add this into my observation list, and I'm really going to try and observe it multiple times at the end of the year. So all in all, this is a wonderful target to observe and image. Everybody knows the Pleiades, that tiny little plough shape that is in the night sky, but when you put some optics on it, if you kind of go with a really long focal length, it kind of gets lost within it because you're looking at the individual stars. So if you can get that sweet spot with a little bit of magnification but a nice focal length, I found my 500mm with my 32mm or my 24mm eyepiece give it a really lovely view, especially deep in winter when it's perfectly about 65 degrees or so up. It's kind of nearly overhead, like alongside that bright winter moon that we're getting. You can really take your time on it, and it moves quite slowly through the field of view. I'd really recommend going and observing this target and seeing for yourself if you can spot that little bit of nebulosity around the stars. Do let me know in the comments below how you get on, and until next time, clear skies.